So cascade, whenever you are talking about turbine, so turbine in which angle, because this is very complex shape, and whenever you analyze fluid flow through turbo machine or turbine, so we assume that this is a very complex flow situation. Okay, uh, and whenever you are describing turbine and you are drawing 2D figure on your paper, it's very difficult to express. So from which direction you are looking at? If you are looking at top and only this portion you are looking at, okay, I am looking at, let's say, airfoil I am seeing, and I am looking at airfoil. So 2 airfoil I can see actually. So 3 and 4 almost hidden. Okay, or I can make like this. I can cut half and I can make it flat. So I can see all 4 airfoils like this. Okay, like instead of blades, instead of putting on one circular hub, I can make on flat hub, and I can put blade 1, blade 2, blade 3, blade 4. If I have many blade, I can put many blades also. So this is called cascade view. Okay, this is called cascade view. Okay, and this cascade view, when you are drawing, we can show rotor, stator also. Okay, what is rotor? Rotor means in pump, you can remember, rotor means rotating, and stator means which is not rotating, static, stator. Okay, so one turbine also will have rotor and stator. Why? You say I have fluid flow from here, fluid is coming from here. Okay, now I have one stator here, I have turbine blade here. This may be my turbine blade, crescent shaped turbine blade also possible. So okay, I made several turbine blade and I made on a flat plate instead of circular hub. Okay, and I will have many stator also. So what it will do, it will give proper angle. So fluid is coming like this. Okay, it will be exiting like this. So when momentum is getting transferred or changed, or direction is changing, so when fluid is changing direction, it will be giving energy to turbine blade. When turbine blade, this is rotor, these are stators, rotors, rotor, stator vane or nozzle. Okay, stator, we say stator vane or stator nozzle, or stator blade also sometimes you say stator blade, rotor blade. Okay, we say rotor blade. Now stator blade, what will do, it will turn the fluid and it will give proper angle of attack to rotor. Okay, so the rotor will be extracting sufficient amount of energy from the fluid. The stator purpose is not to extract energy, it will be giving only the direction. Okay, so stator not harvesting energy, not extracting energy, okay, giving only direction, rotor extracting energy. Okay, and yeah, so rotor is extracting energy, so rotor is output will be proper angle or not, we don't care. Rotor purpose is to get energy. Now if I have many rows of rotors, say one stage in a pump, I told one rotor and one stator is called one stage. So here also this is one stage, stage 1. Okay, now if I have another stage of rotor and fluid is coming like this, that means it is not getting proper angle to enter into the second stage. So what will do, I will put another stage of stator, so that this fluid will be coming, the stator will be deflecting them, it will go to rotor, again it will give energy and it will go out. Okay, so stator is like this, I am drawing stator, you can see stator, rotor, S-T-A-T-O-R, rotor. Okay, stator blade will be giving angle, rotor will be harvesting energy. Again stator blade will be there, rotor will be harvesting energy. Okay, so one stator, one rotor, stator, rotor, it will be there. So one stage stator, rotor, second stage again stator, rotor, stage 2, third stage also stage 3, third stage also will have stator, rotor. So first stage stator will give angle, it will go to rotor, rotor will harvest some energy, energy will be reduced, it will go to stator again, stator will give proper angle, stator is not harvesting energy, again it will go to rotor, rotor will harvest energy, it will give to stator. So, several stages possible, okay, 5, 6, 7, 8 stages also possible. And this I told already that airfoil shape, blade shape can be airfoil type or crescent type or many other type also possible. Okay, this is called cascade view. Okay, one stator. So, from like blade, 1 blade, 2 blade, 3 blade, 4 blade, you are putting on flat plate and you are passing flow through the passage. Passage means between space between rotor and two rotors. Okay, so these are passage. You can see passage. Okay. Now another term is there, meridional view. Meridional view means I say I have rotor, stator, and I am looking at side with along with my shaft. Shaft means the shaft will be rotating. Shaft will be rotating the whole system. Okay, shaft will be giving torque to the whole system. It will be rotating. So I can draw like this. I can draw like this. Okay, and I will have you see this is my rotor, this is rotor, this is my stator. I will be putting different hashing line, stator. Okay, so rotor, stator not rotating. Okay, not, no rotation, rotor rotation. Okay, so rotor will be connected to shaft and rotor will be rotating continuously and stator not rotating. So what will do, stator is here, rotor is here. So stator will be giving my proper angle, rotor will be harvesting, rotating and harvesting energy. Another stator is there, stator will be giving proper angle, again another rotor will be rotating, another stator, another. So one rotor stator, one called stage, stage 1. This is rotor stator, stage 2, stage, and all rotor can be on a same shaft, common shaft. Okay, the stator is not fixed on shaft, rather it can be fixed on housing because it is not rotating. Stator is not rotating, rotor only rotating, so rotor will be on common shaft. Okay, and fluid can be flowing like this, flow. This is called 2D meridional view, 2D. So 2D, I'll write here, 2D cascade view. So velocity triangle. So whenever we are discussing about turbine, even pump also, we draw velocity triangle. Then we try to calculate how much power it can extract. So velocity triangle will tell what should be your angle or angle of attack, proper blade angle. Then how much energy you can extract, what should be flow velocity. So those relationship will be calculated from the trigonometry of, that is called velocity triangle. Okay, let's say frame motion or turbine speed, blade speed u, relative velocity. So relative velocity means when fluid is flowing through the passage, this turbine u velocity or omega into r, omega rotational speed, r means radius, omega into r, and relative fluid velocity, this should not be same actually, there must be some difference, that is called relative velocity. So relative velocity, let's say w, and absolute velocity, absolute fluid velocity is v. Okay, so v, u and v will not be same, so that's why w term will be coming. Okay, so velocity triangle, let's say stator I have like this, I have stator like this, Okay, and I have rotor like this, because fluid will be going this and it will be going like this, rotor will be like this, rotor will be like this. Okay, this is airfoil shape actually, you can draw properly. Then rotor, stator. So rotor u equals omega r. Omega means angular velocity, r means radius. And which radius? Mean radius. Mean radius of the rotor. Velocity. Okay. Now if I draw velocity triangle, it will be looking like this: u, v, and w. Okay. X theta direction. So we'll try to solve one simple problem. We'll see. Okay, so let's see one simple problem. An office desk fan, a diameter of 30 centimeter. So let's say office fan is having like this, diameter 30, and rotates 200 rpm. N equals 200 rpm. So omega equals 2n pi by 60. 2n pi by 60, and entire fan air enters, so air velocity given 3 meter per second parallel to the axis. This is axis. The relative velocity w we have to calculate. W we have to calculate. Okay. So again you draw the velocity triangle. Let's say turbine blade u equals omega into r, and v we have 3 meter per second air velocity. So I have to calculate relative velocity. Okay. So you get omega into r equals 200 into 2 pi by 60 into 0.3 by 2, 3.14 meter per second, and w relative velocity equals v square plus u square. So you get 3 square plus 3.14 square, so it is coming 4.34 meter per second. So this is your answer.